Well, first of all, I want to thank all of you for taking the time to join us this morning, particularly any of you who were at the pub crawl last night. I particularly appreciate your getting up early to join us today. I truly appreciate it. My name is John Buselli. I'm an offering manager within the IBM Quantum organization. My colleague Jay Arun and I, who is our product manager, are really pleased to have you here and looking forward to the subject of talking about really how to assess and apply crypto agility to your organization. It's an omnipresent subject. It's something that's sort of been permeating this conversation throughout the RSA that I've attended this week. And so I'm very grateful and thankful to be here today, and I do appreciate it. So again, thank you for taking the time today. We want to accomplish really three things today in speaking with you. First and foremost, we want to give you an idea of what we're doing in the area of quantum and quantum agility. We want you foremost to understand what we mean by quantum or crypto agility, excuse me. As I've been through the conference this week and in previous conversations over the last several years, this is a term that I think has taken on a multitude of meanings, and part of our objective today is to give you a crisp view from our perspective as to what we mean by this technology and the importance that it has going forward in our industry. Secondly, we want to actually demonstrate some technology for you that give you some idea of how these kinds of capabilities and techniques can really be applied practically in your organization. We really want to make that the centerpiece of our conversation today with you. And then lastly, we want to make sure we have time for conversation and questions. So as we've managed our time today, know that at the end we'll have ample time for that. Part of our objective today is to make sure that we can do our best job in helping to bring clarity to this important subject going forward in the market space. So that's what our objectives are today. Jay,
well,
anything
thank you,
you want
John.
to add?
So thank you again for all of you coming here. I know this is an important topic, last day of the conference, but we all see here, I think, how critical it is at this day and time. Some of you may have been in cryptographers panel where Adi Shamir and Whitfield Diffie and those guys talked about it, how important it is for us to be agile in this space, because we know these algorithms are being developed for post-quantum region that may be a trigger at this moment, but I think we have to build our crypto infrastructure in such a way that it is agile enough, because we don't know how soon we need to do this again. So I think that's the important part. So I will let John talk about the early part of things, and then I'll come back and join him to talk about more of our technology and demonstrate the technology, and also talk about the framework-led approach for the crypto agility. So that we will do.
Thank you.
And then we'll open it up for Q&A. And I would like to request that please come on to the mics to ask the questions, because this session is being recorded, so the other people can benefit from your questions as well. Thank you.
All right. So just to frame where Jay and I fit in the organization, inside of IBM, we're part of the IBM Research Company. It's in the context of research that IBM has its quantum computing organization. And there's really two fundamental parts that we do in IBM Quantum. There's all the work and effort that go into making quantum computing useful and practical, developing quantum machines and making them available into the market space. That's one side of our business. And the other side of the business is what Jay and I represent, is how to make the world quantum safe, or how to prevent the misappropriation or misuse of quantum computing in today's market space. And this primarily revolves today around the potential threat of quantum to unravel a great deal of modern cryptography. That is our primary concern today. And within the quantum safe organization in IBM, we have sort of two fundamental components. We have work and invention that goes to make quantum safe algorithms. For those of you that follow this space, have been looking at what NIST is doing, the algorithms that are near certification, a lot of this work comes from the IBM Research Company. And then we have automation that we're introducing to help accelerate the remediation of cryptography. And this is what really sponsors the subject of crypto agility. And those are the two parts of our particular business. And Jay and I are on the quantum safe side. That's where we fit in. Okay. Just a quick primer on quantum, right? It's not intended to be a physics class, but just to sort of set the stage for today's conversation. When we talk about quantum, there are fundamental differences, obviously, between classical computation and quantum computation. right? The world of classical computing, which has served us well for generations and will continue to serve us well for generations, is based on a very fundamental concept I think most of you in this room understand, and that's the idea of a bit, right? It can be a 0 or a 1, and that's how it's ingrained in silicon. And we use this fundamental mechanism to program and design applications. It will be here for generations. It's not going away anytime soon. Quantum is a fundamentally different principle. It takes advantage of the rather amazing aspects of physical nature, and that is the quantum effect or the quantum concept, right? We are quantum devices. Most natural behavior, most biological systems are actually quantum machines. We certainly are. Photosynthesis is, for example. And it has a couple of interesting properties, right, that exist. And the fact of quantum computing is that we've learned how to understand it, we've learned how to describe it mathematically, and we are now capable of harnessing this for computing power. And it's really quite fantastic. And there are three fundamental principles. There's the concept of superposition, which in layman's terms is the fact that it's, if you can imagine a sphere, no longer is it a 0 or a 1, it could be a 0 or a 1 and anything in between in a three-dimensional space. It's kind of hard to get your head around that, but that's actually how nature works at the subatomic level. What this means practically from a computing perspective is that I now, in a very small space, have an exponentially larger amount of computing power. That's what superpositioning means. The other fundamental characteristic of quantum is a concept known as entanglement. This is where two quantum effects, or a quantum effect, can be aware of another quantum effect, and we can interlace or parlay these to accentuate computing power. It's as much a philosophical concept, I think, as a physical concept, but it actually does exist and it really does work. And if we can harness this power, we create even more exponential computing opportunities. And the last is what's known as interference. Imagine two stones thrown into a pond. They create ripples. Some come together and accentuate the wave, some come together and cancel each other out. And harnessing that property enables us to produce more effectively the probable answer, the peak, if you'd like, of a particular algorithmic process. Quantum devices are probabilistic machines. They're not deterministic. And it's this property of interference that helps us accentuate or more rapidly assume an appropriate probabilistic answer, right? So I've described this in layman's terms, but it's these fundamental concepts that make quantum computing different from classical computing. And that's where we are today. And it's this power, it's this capability, it's the density of computing in a lot of ways that give rise to the concerns that we have about the onslaught to a great deal of modern cryptography, particularly asymmetric cryptography. Now, there's a very famous algorithm, most of you may be aware of it, called Shor's. 1993, mathematician from MIT, or actually from AT&T at the time, Peter Shor, hypothesized that if you had a quantum device of a certain amount of characteristic, a certain number of qubits, he would be able to factor numbers far more efficiently than has ever been conceived on a classical machine. And as it turns out, a large basis of modern cryptography, certainly asymmetric cryptography, public and private key cryptography, relies on this factoring problem. If I make a number large enough, it's extremely difficult for a classical machine to figure out what the two predicates are, what P and Q are. Hundreds of thousands, if not millions of years, and this is an example of an RSA 2048-bit scheme. It's just very complicated. It takes a long time, it's not impossible, but that's why we trust it. Along comes a quantum device with Shor's algorithm. This concept can be unraveled in days, if not hours. And that's the fundamental risk that quantum devices represent. So, a great deal of what we rely on for digital trust, the idea that I'm willing to, enter health records, do online banking, communicate with this kind of a device as one example, relies on this trust. as does a great deal of the modern economic framework. If we can't trust this and this is unreliable, well, I think it's not, I don't want to paint a draconian picture, but I think we can all understand the potential implications if this concept doesn't exist or is not reliable anymore. Now, there's another form of cryptography commonly utilized called symmetric cryptography, which is single key. Now, it's not directly broken by a quantum device, but there are other algorithms, Grover's in particular, which bring brute force concepts to bear using quantum devices. So while not directly impacted, there is a greater risk that it ultimately may also be circumnavigated. And that's why we're concerned about it here. So as an organization, while we're on the forefront of quantum computing, there's almost an ethical responsibility on our part to make sure that we're protecting the world from the misappropriation for these very reasons. That's what we're really worried about here. So, what are the potential implications? Right? I'm sure in other sessions, if you've attended any cryptographic discussions on quantum, we've all heard about the harvest now, decrypt later problem, right? It's a very simple premise. Everything that I'm doing today that is not quantum safe, if it is exfiltrated, could potentially be unraveled by someone misusing a quantum machine sometime in the future. That's the basic premise of this concept, right? Other concerns obviously deal with things like fraudulent authentication, manipulating digital signatures. You know, just imagine if I could no longer trust code signing, for example, right? Or I no longer could trust the benevolent ownership of a document in a database, right? Or I could easily spoof an identity, as an example. These are some of the potential impacts, right? I think we can see that these are rather impactful concerns. Now, in a way, it's a shame that we talk about quantum computing in the future, and I'll get to that in a second, but this harvest now, decrypt later problem is really more of the fundamental concern that we have today. I want to be very clear in this room. There is no quantum machine today that I'm aware of, I think that we're generally aware of, that can actually perform these functions, right? That can decrypt an RSA 2048-bit scheme, for example. But the concern still exists through the harvest now, decrypt later problem, right? And that's one of the fundamental premises that we're worried about, which sort of brings to relief why we're worried about it today, right? So to bring this in a little more relief, just because it's the obvious question that will be asked and I'll answer it now, is when might this occur, right? This is not like Y2K. There is no absolute point in time when we know for certain that we have to do something to go from 2 to 4 bits, right? At best, we have a consensus, right? And that consensus, based on probability and what's coming out of various 3-letter agencies and whatnot, generally have ascribed that we should be considering and worrying about this over the next decade. It could be 7 years, it could be 15 years. Generally, the high density of probability is around that 10-year mark. We also know from our experience in looking back in history that it takes a while to transform cryptography. I don't know how many of you went through a SHA-1 to SHA-2 conversion. You know, looking at the room, I don't know, a lot of young people here, but you know, some of us have been around a bit. We know that it takes about 7 to 10 years for industry to transform. That's the generally accepted principle from what we've seen historically. So the point that I'm trying to make here is not to panic. There is certainly not a moment of concern here. But we're in that nexus now where if we think it's about a decade to come to reality and it's 7 to 10 years to effectively transform, a proper risk management perspective would say now's the time to start planning and effecting change in a thoughtful and ultimately cost-effective, rational way. That's really the business perspective that I think we'd like to impart upon you as it relates to this subject today. Right? That's the premise of what's in front of us. Okay. All right. Now, the good news, and this is the very good news, is that the cryptographic schemes that we need that are designed to replace existing cryptography are almost here in the industry. 2016, the National Institute of Standards and Technology had an open competition. There were about 80 different submissions from around the world, various groups, vendors, consortiums. Give us your best ideas, and let's start inventing the next generation of cryptography that we could feel confident are indeed quantum safe. Right? If we fast forward to June of last year, 4 finalists were selected. One called Crystal Kyber for public key, one called crystal dilithium for digital signature, and 2 alternates for digital signatures, Falcon and Sphinx. It's a great source of pride here in IBM. Dilithium, Falcon, and Kyber were invented by the research organization that Jay and I are a part of. All it means is we know cryptography very well. IBM has been at the forefront of cryptography really since our inception, going back to the origination of crypto with DES and going back 50, 60 years ago. But my point is we're almost at the point now where these algorithms are going to be certified, probably within 2 months. And what this means to the audience is you now have certified, verifiable schemes that you can use to begin to replace existing cryptography with quantum safe cryptography when you impart upon that journey. That's how close we are to the delivery of these new schemes, right? So that's the good news. Now, these are Falcon, Dilithium, and Kyber are based on a different mathematical concept called lattice cryptography. It's not based on factoring. It's a different mathematical problem. It's more of a geometric problem, as it turns out, it's very, very hard for quantum computers to solve that kind of a problem. NIST is not done, however. These schemes have certain characteristics, certain signatures, and they are largely lattice-oriented. They did not want to put all their eggs in one basket. And so, just as a point of order, there is more competition in front of us. There are new schemes that are being evaluated, and over the next 12 to 18 months, maybe a little sooner, maybe a little longer, there'll be new schemes with different characteristics, particularly non-lattice based, but are also designed to be proven to be quantum safe, right? So there's more change coming. And in a way, this concept also leads to why we're also worried about being more agile in how we design and manage cryptography. We know change is coming, we know more change is coming, and it's going to continue. Right? Cryptography may be one of the least well-managed parts of any IT operation. And there's very good reason for it historically, right? We've really never had to worry about it. We always assumed it was there, we applied it, it worked. We didn't really need to manage or maintain it. It was just functionally part of our operations. We're now looking at a fairly dramatic change over time. I have to be able to change cryptography. Well, when you think about it, and there's an old adage in governance, you can't manage what you don't understand. And so in front of us are a series of steps, and this is where agility comes in, of how am I going to affect this kind of a transformation in any sort of economically rational way. Right? And as my colleague will describe, we've been giving this a tremendous amount of thought as well, and that really forms the basis of the cryptographic agility frameworks. Okay, just a quick point. Where is industry at this point? Where are governments? Where are regulations? What's driving this? We've talked about the risk. We've talked about the availability of quantum. We've talked about the potential effect. But where is government in this? Well, in the United States, there's actual legislation signed last year that has established the requirement for critical U.S. federal infrastructure, which actually extends into things like utility and supply chains, to transform by 2033. Notice the timeline. It's about that decade that I had mentioned previously. I don't think it's accidental, actually. Now, it's not binary, but rather there is a progression that they want critical infrastructure to undertake to adopt quantum cryptography to address certain issues like code signing, firmware, and things like that. So there'll be a graduated plan, right? At least as it is represented here in the US, this is actual legislation that's in effect. The impact, of course, to vendors like us and others is that we're all moving in this direction. This is the carrot, if you'd like, that's driving industry transformation. Around the world, it's not yet as mature, but there is a series of regulations, there's a series of movements, there's a series of recommendations in many different countries, and we're tracking all of this, that are essentially providing guidance, outlines, and recommendations that are effectively doing the same thing. And I think we'll see over the next 18 to 24 months more specific implications in various countries as legislative acts mature. Right? We're going to share all these slides with you, by the way, and there's resource slides that we have that give a great deal of depth as to what's happening around the world in specific countries with regulations and so forth, so just so you understand that. All right, my last slide. One of the things that I wanted to highlight here, and it's extremely important, is as an entity, we may work with individual companies trying to help them transform, but it's not enough, right? You know, the weakest link in the chain theory demands that any entity understand the implications of how it interoperates with its various trading partners. So part of the effort that we have and other vendors who are part of these consortiums are trying to do is bring education, awareness, and movement within various industries to transform collectively, right? Telecommunications, for example, has an organization called the GSMA. We've been working with them for several years. They've been working with the major telco suppliers. They've been working with their various equipment suppliers to set the frameworks and guidelines for transforming the telecommunications backbone to a quantum-safe future. Right? Similarly, there are organizations like the EPA in Asia and NACHA here in the United States and North America around payment backbones. Right? How can financial institutions come together and work collectively to transform the payment infrastructure, which is vital really to every industry, right? And then there are other general consortiums like the Linux Foundation, work that's going on in NIST itself with the NCCOE or in NCOE, which is a consortium of vendors to come together and create interoperability of technologies for beneficial use out in the market space. My point is, as you examine this space, you should also look to these kind of entities within your respective industries for guidance and alignment, because it really becomes important over time in terms of how your respective industries are moving forward. And there's a lot of good information coming out of these organizations as well. All right. So with that, what I'd like to do is turn it over to my colleague and get into the more substantive part and get into the role of agility within the cryptographic story. With that, I'll turn it to Jay.
Thank you. So I think you have heard a lot about that, where the cryptography-related changes are happening all the way from government and industries rallying around that. But let me share some more insights that what's the best approach for us. So we, John and I and our entire team, over the last 18 to 24 months, we have talked to over 300 different enterprises. We do have about 100 plus, you can say, different type of meaningful engagements, and half of them are paid engagements as well at this point. But I think collectively there's a knowledge here that how do we get started on this journey to quantum safe? And there are key steps that we have been looking at. So first thing is, obviously, when we think of cryptography, as John mentioned earlier, in the past, we haven't really cared about these things as much as we wanted to, because I think it was the cryptography used. I was the programmer. I remember when I started my career in early 1998, developing the firewall software, proxies, VPNs, and then went to IBM's WebSphere application server security platforms. I remember how we used to develop the security of the application, security of the data, as we looked at what algorithms needs to be used and what is the guidelines from enterprises, and we just implemented them. Nobody has been tracking them. Nobody has been thinking holistically that how do you really need to build them? Do you have a tracking mechanism? Do you know where the cryptography is being utilized? Nobody is having that full visibility of those things. So discovery becomes most important today, because unless we know where the cryptography is or cryptography artifacts, when I say artifacts, like your crypto libraries, crypto functions, crypto methods, the algorithms, the key sizes, key length, all of those things are very, very important. How do you know? I don't know if you ask any CISO, they might say, I might have some idea, but I don't really have the full inventory of my enterprise that can tell me where my cryptography is. So discovery is the first step. And what do we mean by discovery is making sure that you find where the cryptography relevant artifacts are in your system. And then also you create and find the dependencies, because sometimes what happens, I have created a crypto library method function and maybe I'm calling it in the other file, so the dependencies are lost. And then you don't know where the usage of that specific function or library is done. And that creates a lot of problem in terms of finding the true or single source of truth for cryptography. And that's one of the idea that we have been sharing, and it's coming out as a standard part of the software bill of material. Many of us know if we buy a software, procure a software, we know what things it requires and what version and what not. So that same concept is called cryptography bill of material. So we need to have a single source of truth across the cryptographies as well. And this standard will drive a lot more changes in the industry. When you get the commercially off-the-shelf applications from major vendors, they should also be giving you the CBOM associated with that application. So that's once you have that full visibility of your discovery of the cryptography is one area that you can get from your applications. But other challenge it comes or becomes as well, that how do you see the cryptography when you can have access to your application source code? Because you might have deployed those applications, only thing you can see is in your network, right? What information is coming in and out of a network endpoint where your application is running. So that's one of the dynamic point of view you need to bring from cryptography perspective. And that's the area that we talk about, observe, monitor, where the cryptography handshakes are happening within your IT landscape. And you bring the static view from the application side, but also a dynamic view from your network side, bring them together and create your enterprise-wide inventory and monitor that, prioritize that based on your business compliance rules, regulations that you may need to do, like some healthcare might say HIPAA compliance data is kept on this system, this application, this database, making sure that that has to be protected first. So you prioritize based on your business priorities, and also look for the areas that how you put that priority for remediation, because that's the last step that you need to talk about or do is basically transform. What we transform means remediating your business applications, data, or network to be quantum safe. And when we say quantum safe, it's not simply replacing the algorithms, because as we talked about, there are lots of dependencies that run around the cryptography implementation. So we need to make sure crypto methods, functions, libraries, algorithms, all of the things are considered as equal citizen as part of your transformation journey. And that requires, I think, one of the important topics you see in the middle of the chart here is crypto agility, because while we are going through these processes, discovery, observation, transformation, it's not one-time effort, because we see these things will be required on an ongoing basis as we see the anticipated changes in the algorithms or the cryptography in general. And that's the area that we need to bring this topic of crypto agility. How do we bring the crypto agility into our enterprises? So that's one of the important topics. What I would do is also share with you a little demo of each of these capabilities that we have been building or incubating around discovery, the observation, as well as the remediation side. But let me share with you what crypto agility is. I think a few years back, or we were thinking that, you know how that 5 blind men and elephant story, that everybody had some different concept what crypto agility would be. But you won't be surprised that a couple of weeks ago, or last week itself, the NIST, the National Cybersecurity Center of Excellence group, they had about 169 different vendor participants who are helping on the PQC migration. We got all together and we talked about what crypto agility should be, because I think everybody has different point of views. And there were few common design principles that we all came up with. And I'm gladly sharing some of the work that we have done and the point of view here. This is not the ultimate point of view, But I think this is a point of view that we all can think and start from somewhere. If I look at the crypto agility, I think the definition, we can still have an opportunity to tweak it, but in a nutshell, it's an ability for an organization or a system or a platform or a network or an application to do something quickly. What is that? When you have a cryptography update required for whatever reason, you can do that quickly. You can change the cryptography quickly when your regulations require, like we know now some of the regulations federal government is mandating. Or you can monitor how it's being used. Is it used properly or not properly? I think that's the important part. But also quickly retire if it's out of date or obsolete. So I think that's the fundamentally, I think in a nutshell, this is what we should be able to do, and that defines that how we become, but it's easier said than done. The definition is fine, but in general, we need to make sure that how we progress that. So this is, it's a framework, and we can start somewhere. I think there are 3 guiding principles that we have to look at from crypto agility perspective: architecture, automation, and governance. I'll go through the details of each of these. What do we mean by that? When we talk about the architecture, how do we build our application infrastructure, our network infrastructure in such a way that it's modular enough? There is an abstraction layer of the cryptography so that when we need to make the changes, it's easier to make the change. New methods, new functions, new encryption algorithms that we can quickly change. So this is fundamentally very, very important, that how do we abstract the cryptography hard coding from our applications or even the network side as well. And those are the ways when we are writing the new applications or modernizing our existing applications, we need to make sure that we can have those patterns and abstractions done so that it's easier for us next time you write a new application, or even the applications that we modernize now from crypto perspective. I say you call a centralized service where you might have encryption, key management, certificate management capability, and you can simply call, get me a new algorithm, get me a new key, get me a new certificate, and it will be calling a centralized service. That way you don't have to always change the code itself. So I think that's one of the typical case. And then we also see that how we will see the sidecar pattern is basically you are providing that capability on the side for the crypto implementations, right? Lots of things I think to be considered in general, but I think it's how you create that infrastructure architecturally, applications, network, and how your data is kept, and making sure that the implementations are possible for you to be in a modular way. Next part is automation. So obviously, I think while we build the capabilities, how can we ensure some of the things can be done dynamically? We talk about, I'll share the tool in terms of discovery. So can your discovery of the cryptography things can be done in your CI/CD pipeline in DevSecOps. So every time you are doing, it's automatically running those things and finding if there are crypto vulnerabilities or not. So that's the type of the dynamic configuration, dynamic implementation, so that you can easily change those things. Infrastructure should be supporting you to make those changes easily in an automated manner. So that's the part of, I think, in crypto agility for the automation. Governance is very, very important, that how do you have monitoring capabilities in place, because we did not have them in the past. The observability part, the policies that you can deploy. Yes, everybody has the policy management tools, but how many of us have the crypto-specific policy management frameworks and capabilities in place? How many of us are actually truly doing, you have seen in the show floor, application security posture management, data security posture management. We haven't seen yet the crypto posture management yet. So I think that's the type that how do we manage the posture of cryptography in general? And then also making sure that we are using the standards along the lines, that standardizing the processes that we have in place so that it's easier for us to implement the changes when needed. So that's the part. So governance is very, very important. Many organizations are creating a small team, what we call Cryptography Center of Excellence. So the COEs are basically driving this governance so that they have the right policies, right monitoring capabilities, right standard processes in place so that it's easier for them to implement these changes. So let me take a moment here and do the demo so that I can show you how the discovery and the observation, and also I think some of the early capabilities around the remediation as well. Okay, so this is working. Okay, we talked about the one of the capabilities that we have is related to explore, right? The discovery part. One of the things that within our business applications, it's hard to find where the cryptography is hidden. So in this tool, it's called IBM Quantum Safe Explorer that's running on my laptop. And as a developer, if I would be running this, there are multiple ways that I can interact with this tool. So it can be one of my integrated development environments, IDEs that most of the developers use, VS Code. So I have VS Code plugin for this one that I'm using here. But it can be also available as a command line interface you can call in your CI/CD pipeline, or an API interface that you have in your DevSecOps that you can call directly from there. So it's automatically running every time you write new application. So this is a tool. We call IBM Quantum Safe Explorer. What it does is if I'm a bank, I have a fund portfolio analysis set of applications. They are written in Java, Python, C, C++, and Dart or something like that. I have some jar files as well. But when I run this tool, what it gives me in a nutshell is listing of all of the cryptography specific artifacts. So for example, when I run this, you see here that there were 66,767 lines in this set of project, 744 files, and about 52,000 plus crypto methods that have been found. And then especially within those methods that we see cryptography relevant or usage that we have found across all of the programming files were about 1,603. And what I can do is actually go individually and find out in C programming language related files how many crypto functions have been used, what crypto libraries have been utilized, and then listing of all of those artifacts. So listing of all of the crypto specific artifacts that you can see here. And that's available for each of the languages if I go to Java or Python. But more importantly, as a developer, I would like to make sure that where that cryptography specific usage is. So I can quickly go to the code level and line level and find exactly that what function method it's calling out as a vulnerable from quantum safe perspective. And then I can see some of the metadata information that it's calling a particular algorithm, the digest size, block size, other information along with this line. What we do in this tool is, as I mentioned, this is a discovery tool, but you can also have a common standard format, what I call the cryptography bill of material, that's the CBOM. So it's an extension of SBOM, which many of us use. There's a crypto asset class that you can define that, and it's actually automatically generate a CBOM. So this is the part, it's generating the CBOM with all the artifacts that we found in the entire project when we scanned. So this gives you more or less in terms of a crypto exploration or discovery part. Once you have those discovered, as I mentioned, this gives you the application point of view, which is kind of more static. What happens in your network is the dynamic point of view you need to bring. So this is an example of one of my business unit, which has about 4,550 network endpoints, a small network. Within that network, what we do is we find which kind of cryptography libraries are being utilized and what kind of TLS handshakes are happening from those network endpoints. And I can see all of them. And when we know that TLS 1.1, 1.2 are not quantum safe, so we have to look at how many of them are TLS 1.3 and onward. So we get that visibility. So you have listing of all of those things that you find, that which country you have this network endpoint, what host and port, what specific protocol versions are running, what cipher suites are being utilized behind those, and then what's the cipher suite strength in nutshell. So this is basically a point of view that we bring on top as well, the visibility from network perspective, that what's the strength of your cyber suites, and that I think in a nutshell defines the posture that you would have in place. And then you can define based on these things the set of policies that you need to have around your enterprise. And those policies you can look for that how many policies are violated, and you can track them on monthly basis. But more important thing is that in this tool you can also infuse the CBOMs from other vendors. Like one we have scanned from Explorer, this was the fund portfolio analysis, that application we scanned, and we know behind which port and where it is running, what applications they have and where those things are. And we can have all of that inventory together right here. And you can create the tickets if you want to have your development or DevSecOps teams to really take an actions. And then application-specific insights, that where the applications are running behind which endpoints, and you can get those details as well. And you can create your own specific policy based on the type of host, port, application, based on your business regulation and compliance requirements. Okay, so this is about the observability tool, as I mentioned, and give you the dynamic point of view, creating the posture as well as policy. But most importantly, one other thing is that how do we, let's say I find which applications are not quantum safe, is there a way for me to quickly remediate them, right? So I think the agility part also comes in from that perspective. And I would like to share with you we know that on this conference, everybody is talking about the Gen AI. So we have used the large language models to train, and there are two of those models that I have here. Those are running as Docker containers here on my laptop. One is for the crypto vulnerabilities finding. So I have scanned the code, as I know, using the Quantum Safe Explorer, but finding the vulnerabilities, understanding those vulnerabilities, because many of us do not have an ability to have or hire the cryptographers or lots of cybersecurity experts. Skills are short. But how do we help development community to understand what challenges are, and then how they can also remediate them with the help of LLM-based or Gen AI in general? So I have two of these models running, LLM-based models. One is the Crypto Vulnerability Finding Manager, and then other one is the Remediator. And how it works is basically you have set of files like I have shown you earlier, and I simply run the crypto vulnerabilities on that, and it finds the crypto vulnerabilities as you see here, and it gives the enough insights and details on each of those. For example, in this file, default value encryptor.java has 4 of these vulnerabilities, and it gives enough detail that individual developer would understand without knowing the lot of or like security engineering skills. In this example, I have been a developer in the past, so I can understand that when you pass a string for a password, there could be an opportunity to have added things in general. So what we need to make sure that you give a specific character limit. If you are asking for a password of 8 characters or 16 characters, be precise in that so there's not enough exposure to vulnerabilities in general. So that's an example. Like sometimes you can say, okay, what algorithms are being used? Is that the algorithm using 128-bit of your key line size? Can you have it 256 because it is not secure? So things like that, we have to make sure they are done. And then you can find those things in your code, and let's say I found those vulnerabilities in this application, I can kick in my LLM-based remediation to remediate the current file, and it will run, and the right-hand side window you see on the top is basically the recommended file that you can do the remediation. So this suggests, for example, this particular function where the vulnerability was, the suggested code is right here. So individual can look at how we can really go through this. And then also I think you can accept all the changes or accept the selected changes, like simply how we do in the diff or Word document in general. So this is, I think, one way that how we can bring agility in general using the Gen AI as part of our application remediation space. So I'll take a pause here because I know we are running out of time, and I want to give some opportunity for us to have Q&A so we can answer some of your questions in general. Yeah, I think this is the last slide, which I think the steps for us to really go from here to the crypto agility in general. So we talked about the 3 key steps. Obviously, discovery is most important. making sure that where those you need to prioritize based on the discovery. And then as you begin the preparation for the transformation or remediation as such, and making sure that you follow your business guidelines from compliance and regulation perspective and build those capabilities that we do not have today. And we all know that it's not you all, even we, the providers of these technologies run into from crypto agility perspective or even the skills perspective we don't have. So thank you again. We are opening it up for questions if you have any.
There's obviously a lot in the discussion we've had, and the idea of showing you automation was to give you a glimpse or maybe a sense of hope about how this process can work. We're more than happy to answer questions at this point. So please, go ahead.
A quick question. So in terms of the artifacts you're scanning, you're looking at static code scanning, I'm assuming, and config files, and perhaps an assumption of metrics on the API usage and the protocols. Is that what it is?
Yes.
Yes. Yeah.
Hi.
There's an amalgamation of things, I mean, on the static side, but also understand we're collecting a great deal of information off the network itself as well. Equally important. Yes.
Go ahead, please.
Hi, you had a slide up about the different partnerships kind
Yes.
of globally.
Yes.
I was just curious if you could talk about kind of the resourcing kind of globally, what kind of international frameworks are kind of behind that? Sure. Is there a good kind of diplomatic channel to help facilitate this?
I'll try to answer your question, and if not, you can correct me. There are a number of consortiums. In fact, most industries have some sort of consortium where they get together and establish rules, regulations, guidelines, standards, and so forth. The GSMA, for example, is truly a global organization. There are about 20 major carriers now, and pretty much all the equipment suppliers are part of it, and they are establishing global standards. In the payment world, EPAA and NACHA are embarking on these efforts. EPAA in the ASEAN region announced 2 weeks ago at Money 2020 their entire initiative to move their membership or educate and begin to establish new guidelines, rules, and regulations. NACHA is in North America is beginning to establish that. The Linux Foundation, the Post-Quantum Cryptographic Consortium, which is an amalgamation of vendors, right, as a brand new entity within the overall Linux Foundation, has established a post-quantum cryptographic subgroup, and it's essentially doing what the Linux Foundation does. That is also global and expansive. And COE in the US is really an American-led, but it also has international technology providers, and we're all working together to create interoperability and enforce standards. MITRE, which is in one of the other consortiums I've mentioned, again, is an amalgamation of vendors, ourselves, Microsoft, AWS, Google, we're all part of it, with many different sub-work groups establishing education standards, interoperability standards, CBOM standards, the list goes on. I envision more of these will occur. It's the nature of our industry, it's the nature of things go. That's sort of where we are right now, if that helps answer your question. In the resource file that will share with you, I have drilled into all of these associations and their working files, their websites, and things of that nature, all right? Okay, next question.
Yeah, sure. There's been a lot of discussion around crypto agility in the software space.
Sure.
But what about hardware? I work for Intel. It's a humongous challenge for us, right, as we're looking for post-quantum crypto and PQC implementations, that go beyond, next decade or so. When you have hardware that is deployed, it is very difficult to patch, in some cases unpatchable, right, if it's a ROM or an RTL implementation.
Yeah,
or
so
whatever.
I think
what's your position?
I think you remember, I know I haven't delved into the details because of the time, but if you remember the automation aspect as a guiding principle in the crypto agility, where we talked about that you could have the infrastructure as a code, as a sidecar pattern. I think those are approaches that how can you quickly have the firmwares updated, new algorithms in the crypto cards that can be implemented. How can we detect those hard codings from those? I think that's one of the approach, and we have like our Z systems, which has crypto cards there, so we are evolving from that perspective. But I think that's one of the concerns, and we all as an industry have to find the ways that how we can use those sidecar patterns to really implement them from hardware perspective, firmware perspective, and making sure that can the crypto cards are the things that we can swap easily and have maintained the currency on those from the algorithms updates perspective. So I think that's how we need.
There's clearly a dependency. And, I would envision that as the algorithms become more clear in their deployment, which is imminent in some cases, hardware will finally be able to invest in proper infrastructure. It will take several years. I mean, you know as well as we do. It's not going to happen overnight. There are a lot of dependencies, which is why the transformation time frame is elongated, as I was describing earlier. All these things have to come together.